Good day, students. Today we're going to look at a problem on page 97, practice 4 of your Math 1026 booklet number 2, and this deals with max-min problems. Okay, and I'm going to do a series of 3 problems, 3 videos. The first one I have here is probably the easiest of the 3 because, as you notice here, have a look here, the equation is already given. And when the equation's already given, the problem tends to be a little bit easier, of course. You don't have to find the equation. The next 2 I do in this series, you'll have to actually find the equation, the quadratic equation. Now, how do I know it's a quadratic? Well, it describes the height of a dive, okay? As you can see, Fatty's height, h, the letter h means meters above water, and t is the time in seconds, okay? So, and this is a very common type of quadratic equation. Now, how do I know it's a quadratic? Well, it's the same as y equals ax squared plus bx plus c, isn't it? Right? Except we're writing it as h equals negative 5t squared plus 6t plus 3. So we know that instead of using x here, we're using t. So t in this case is the same as x. So x is the t variable, right? And we know that y is the height, the h variable, right? Y is the same as height. And they could have also written it as h of t as a function of time. That would be the same thing as well. They could have written it like that. So when you recognize a quadratic, and that's important, max-min quadratic in this type. Okay, so let's get rid of that and go through the problem. Now, so we have this quadratic. What do we do? Well, the key words to look for, of course, are max-min, right? Maximum, minimum. And when you see that word, it tells you that what you got to do here is find what? What does maximum mean? See, I see it right there. What's the maximum height above the water? Well, if we did a rough sketch of this, he leaves the board at 3 meters, and I know that because that's the y-intercept right there, 3 meters, because when x equals 0, the y-intercept will be 3. And he jumps off a diving board of some sort, goes up in the air, and comes down in the water. It's a very simple parabola like that. So we're asked to find its maximum height. Well, that's the maximum height right there, right? Now what's that point called? The vertex, that's right. So we're trying to find the coordinates of the vertex. That's what we need to find, the coordinates of the vertex, so we can find the maximum height. However, we're going to have to find the time first, because you always find x first. Find the time it takes to reach that maximum height. Okay? Now, we'll double check it on our graphing calculator after, but let's have a look at how we tackle this problem. When you see that key word, and that key word is maximum or minimum, okay, what are you going to do? You're going to find the vertex. Find the vertex. Now, how do we find the vertex from general form? We know that. We know that x is minus b over 2a from general form. Well, in this case, of course, it's not x, is it? It's t. Use the variable that they're using. So x is the t variable. So the first thing we're going to do, here's step 1, find the time. Right? Find the x variable, or value, I should say, of the vertex. Alright, so what's a? Let's have a look. Do you see what a is? A is the coefficient of the squared term. Right? See how I got that? A is minus 5 right there. Okay. And b, of course, is the coefficient of the x term, or in this case t term, and that's positive 6. So there's my a and b. So we plug that in to our simple. Now you have to memorize this little formula. This is important. Memorize this fact. Okay, that's an important fact with quadratics, that when it's in general form, the x-coordinate of the vertex is minus b over 2a, which is also the same as the axis of symmetry, right? Alright, minus 6. Okay, what happened to my 6? There it is. Minus 6 over 2 times negative 5. So I get minus 6 over minus 10, or 0.6. So what does that mean? That's time now. Remember, that's t, and t is time. So this is the time in seconds. That's not the height. 0.6 meters, not very high dive, is it? So time in seconds is 0.6 seconds. Now how do we find the height of the dive? Well, the height is the y value, isn't it? And how do we find the y value? By simply plugging it back in. So y in this case is the height, which is minus 5 times t squared. But now we know what t is, 0.6 squared, alright, plus 6 times 0.6 seconds plus 3. Now let's bring up our graphing calculator and do that on the calculator. Let me clear that, should type it out for you. Minus 5, open bracket, 0.6 close bracket squared, my square button, plus 6, open bracket, 0.6 close bracket, plus 3. Enter. And it's 4.8. So this comes out to be 4.8. Now what's that? That's meters. Remember, that's h, which is meters. Okay? So our vertex is what? Our vertex is 0.6 for x and 4.8 for y. In other words, time and height. Now how do you read this? Now write it. It's a word problem. Remember, a word answer. So this says, all right, in 0.6 seconds, okay, Fatty reaches, R-E-A-C-H-E, reaches a maximum height of 4.8 meters. That's what a vertex tells you. Okay, so that's the solution to number 1, page 97. Now, the next 2 videos I'm going to do also solutions to 2 more word problems where you have to find the equation first. So have a look at those.